10-second countdown. Hey everyone, welcome to MathTalk. I'm your host, Brian Heisler, and my team and I are coming to you live from Palm Beach County for an awesome session. If you've been following me on social media the last couple of weeks and almost a month or two, you'll know that we have put out some requests for some questions and comments specifically for this live session, because this session is all for you. It's meant to answer the questions that you have, the comments that you have, and to help you out. And so for everyone that has sent in questions and comments on things they want me to talk about during the session, I appreciate it. Thank you. We're going to make sure to cover that in a little bit. And shout out to you for doing that. As we're going through this live session, if you have any questions you want me to address, go ahead and drop them in the comments section, and then we'll make sure to address them throughout. But before I get to those questions, I do want to go ahead and kind of talk a little bit about an overview of the GED and some of the things that have been requested for this session. So some of the comments and questions that were sent in were asking if I could review kind of like an overview of the GED and the math test. And, there were some questions about specific topics such as slope and multiplication and division, and some other things like that. So I'm going to go ahead and address some of those. I'm going to reference a couple of websites as well, give you some tools that it should be able to help you out. But again, if you have any questions or comments, go ahead and drop them in the comments section, and we'll make sure that my team lets me know that they're there so I can help address those. So with that being said, let's go ahead and get started. So the first thing I want to do is kind of go over like an overview of the GED math test. There's a lot on the test, and obviously it's going to help you out a lot if you know what to do to study, what specific topics, what content, because the more narrow of a research you can do to study, the better it's going to help you out. And so I have found this information on the GED website, which I'm going to go to in a little bit. But to give you a broad overview, the GED math test is 115 minutes. It's just shy of 2 hours. There's two different parts to it. The first part is what we call the non-calculator section. It's about 5 to 7 questions, and you cannot use a calculator. It has to go straight from the mind. Or the notes, if you want to use notes and scrap paper. Not notes, but scrap paper. Sorry, I want to make sure to specify that. But you cannot use a calculator. Once you're done with that section, there's a little break in between for the transition into giving you a calculator if you want that, or you can use the one on the screen, and you'll jump into the main part of the test. In the whole test, there are 4 different broad topics and categories that will be found on that test, and those are basic math, geometry, basic algebra, and then graphs and functions. And so what I'm going to do today is I'm going to show you a resource on the GED website that you can go to get more specific information about this. And then I'm going to kind of break down those different categories, give you some specific examples, kind of explain my thought process when I go through those questions, and hopefully that'll help you out a little bit. So with that being said, I'm going to go ahead and show you on the GED website real quick where you can get this information. So if you haven't already created an account on GED.com, make sure you do that. You're going to need an account with GED.com to take the GED test. And once you have an account, you're going to log in. You're going to get a screen that looks kind of like this. And because we're looking at the math test, I'm going to go ahead and go right here where it says math. I'm going to click right there, and it's going to take me to that screen you just saw a minute or two ago. This is great information for you to use. It has information, like I said, the time of the test, the parts of the test, the topics, and then the cost for Florida. If you click on each of these, it'll give you a little more information. So I encourage you to go and read that information, about the 2 different parts as well. There's some good details there, information about the calculator, that break I mentioned, but I encourage you to definitely take a look at that. And then if you continue to scroll down, there is some more specific information about those 4 different categories. And this is where I really want to get into some detailed information for you that's going to help you, and some specific examples. But what's great about this, and I really love this piece about the GED website, is that if you were to take any one of these 4 categories, the basic math, the geometry, the algebra, the graphs and functions, and let's say you click on it, it's going to bring you to a page that's going to show you 9 or 10 different skills within that category, as well as a example and some definitions to promote that. So this is, skill 10 of 10. There's a thing that says it's multiple step problems that use ratios, proportions, percents, and they give you an example of that below. And like I said, there's 9 or 10 of those for each of the different categories. So I encourage you, again, create your GED.com account if you haven't yet. If you have, go into that. It's right from the home page. You can click on either one of these and go through those examples. They're going to give you questions that are going to be similar to the ones on the test itself, so it's going to help you practice the most and be a great benefit to you. So again, once you click on the GED.com website, you'll be taken to the home page. You can just click right on this math icon right here, and it'll take you to that information. Give it a second or two to load, and it'll go right there. So I encourage you to check it out. And obviously you saw as well, there's the other subjects that you can check out too. So with that being said, I'm going to go ahead and go back to the workboard that I have, and we're going to take a look at some helpful tips and tricks and information that I have come up with as part of the overview for this test. So what I want to do is kind of give you some information about each of the 4 categories, things that I've kind of looked at as I prepared for different videos, and some things that hopefully will help focus your study when you're looking at those contents. So basic math. Basic math, you're typically going to find those types of questions on the non-calculator portion of the test, right when you start off. And there's a high importance on understanding numbers. And what I mean by that is, like your multiplication tables, comparing fractions and decimals, looking at exponents and rules of exponents, and looking at things like that. So I really encourage you to study that information. I would focus your attention to learning not only the decimal values of some common fractions, like a half, third, fourth, fifth, sixth, seventh, eighth, all of those. They're going to come in handy because, there may be questions on asking you to order numbers that are both fractions and decimals. And so if you're able to convert fractions into decimals, like I do when I see those types of problems, it just makes it easier for you to organize them or order them from smallest to greatest, greatest to the smallest, etc. So we're going to look at an example of that a little bit. And then as far as, looking at numbers themselves, I highly encourage you to start memorizing and studying the first 10 squares and square roots, and then the first 6 cubes and cube roots. What I mean by that is, 1 squared, 2 squared, 3 squared, all the way up to 10 squared, and then the cubes, 1 through 6, so like 1 times 1 times 1, 2 times 2 times 2, etc., all the way to 6. Because that's only going to help you out when you get to looking at simplifying problems, simplifying expressions, and looking at questions that are about basic math. And again, we're going to look at some examples of those a little bit later in this session, but I want to kind of get you to understand the types of questions you may see for basic math. All right. And again, there's several other pieces to that, but these are some of the ones I wanted to highlight. Okay. So let's go ahead and look at another category, geometry. So geometry, there's really only one thing I want to highlight in geometry is that there is a formula sheet that you're given on the GED math test. It's built into your test itself. But I know at the testing centers that we have in Palm Beach County, they will give you a hard copy of it if you wanted to have it, to kind of touch it, feel it, as opposed to looking at it on the computer. But the good thing about that formula sheet is, one, obviously it's super useful. There's all the formulas you need on it. But the even better thing is you don't have to memorize formulas. They're all there for you. So whether it's formulas about area, perimeter, volume, surface area, slope, all kinds of different formulas, they're right there for you. So while you don't have to necessarily memorize it, I wouldn't even really, I don't know all the formulas off the top of my head. I refer to that sheet frequently. But I do encourage you to kind of look it over, become familiar with it, because you want to be able to know kind of where to look on that formula sheet when you get to certain problems. And I'm going to pull it up in a little bit so I can kind of give you an idea of what that looks like and what I mean by that. But there are a lot of formulas on there. And so to give you an idea of what that looks like and what I mean, I'm going to go back to the GED website because, again, the formula sheet can be found on there. And if I go all the way toward the bottom, you'll see that the math formula sheet is right here. It's going to load, and here it is. So I'm going to zoom in a little bit. So become familiar with the layout of this sheet because it's going to help you know where to look for the certain types of problems that you have. At the top, you have area, and then perimeter, surface area, volume, and then some specific definitions about data, like mean, median, and then some algebra where you get to slope, equations of a line, quadratic formula, Pythagorean theorem. Those are all things that we're going to look at a little bit later in this session. So it's going to help for you to know where these are. But even one step further, like I said, you don't have to memorize these formulas, but you want to know how to apply them as well. There's lots of different letters that represent variables. And so you need to know, like, what do I plug in for this letter, this variable, and how do I use this formula? So we're going to look at some examples on how to apply the formulas, but it's really important that you kind of have an idea of the layout of this as well. All right. And again, at any point during this live session, if you have comments, go ahead and drop them into the comments section. Any questions, I'll be sure to address those for you. All right, so we're going to move on to basic algebra. So basic algebra, the things that you're going to see in that content area are things like expressions and how to write expressions. You're going to see word problems, how to solve word problems using equations, inequalities, things like that. And then, of course, algebra. You're going to have to solve equations. You're going to have to solve quadratic equations. And so knowing how to approach those problems is going to help you with this content area. When I look at expressions, what I really mean by that is, when you have a bunch of words that are put together and you're asked to write it in letters and numbers. So if you see things like more than, when you see the phrase more than, it means add. 3 more than a number is 3 plus a number, 3 plus x, x plus 3. When you see less than, that means to subtract. It's the opposite. So 5 less than twice a number. That means 2x minus 5. And then common phrases I've seen is twice. If you do something twice, you do it 2 times. So it's important to know those kind of phrases and how to translate them into numbers, letters, and expressions. And then when you get to equations, one of the rules I've always been taught that's helped me out a lot is equations are solved by doing the opposite operation. If you want to solve an equation, just do the opposite of what's happening in that equation. What I like to do, I think has helped me a lot, and helped some of the students that I've taught in the past, is I will kind of read the equation out loud, starting with the variable, which is usually x, and I'll read out what's happening to x step by step, because I know that once I read it out to solve it, I just have to do the exact opposite. And so there's some examples we may look at to explain what I mean by that, but remember that equations are solved by doing the opposite operation, working backwards in a sense. So I hope that helps with the basic algebra, and we'll get to some examples a little bit later. And then the last one I want to cover, the topic is graphs and functions. So this is an interesting one because I've actually gotten some specific requests that we'll cover a little bit later. And the types of things you're going to see on graphs and functions are slopes and obviously functions, but specifically slopes. And I would encourage you to learn as much as you can about slopes. And there really is a lot to learn. So there's several different examples we're going to go through later in this live session about slopes, whether it's graphing 2 points, finding the slope between 2 points, finding the slope in an equation of a line, finding the equation of a line. There's all kinds of different things you can see with that. and they kind of build off of one another too. So you can kind of start from the easiest piece of graphing 2 points to build to the next step of finding the slope, and then the next step finding the equation, et cetera, et cetera. And it's really going to help your foundation with graphs and functions. Also, obviously, you're going to see some functions on the topic as well. And the things you're going to see that ask about that, you could be asked to say, you know, when is a function defined or undefined? You know, when does it actually exist? Or you can see functions represented as tables, or graphs, or charts, or things like that. So the more you can practice things like that, the better you're going to be at the category of graphs and functions. And like I said, we're going to go through lots of examples of slopes because I had a request specifically for slopes. So we're going to do a lot of that. Okay, so that is kind of my overview of the GED math test. Like I said, there's lots more information that can be provided to you in that GED.com website, but you have to create an account or have an account to see all that great information. So if you haven't done that, go ahead, go to GED.com, create an account. It's super easy, and you have lots of resources available to you to help study for the GED.com, the GED math test. While you're there creating your profile, make sure you go ahead and add Palm Beach County as your Palm Beach County testing site. That way we can, you can communicate with you and give you great information about our programs as well. So with that being said, I'm going to go ahead and take some specific examples that I put together. If you have any specific questions or comments you want me to go through, again, drop them in the chat. Whether it's on YouTube or Facebook or Instagram, we're monitoring all of those. So just drop them in the chat and I'll be sure to address them as soon as they come. So we're going to take a look at one right now and see with that. Okay, so we have a question that says, I need help with GED word problems. Are there any hacks? Great question. Great phrasing, by the way, too. I like that. Any tips, tricks, and hacks, to make things easier. That's great. So what I would recommend is, with word problems, which we're actually going to get to in a little bit. I have a couple of word problems set up, so I'll make sure to address those when they come. But I always break down the problem as simple as I can. Even if that means underlining specific words or numbers or highlighting them. There's some tools on your actual screen where you can highlight phrases and numbers. But the simpler you can break it down, the easier. And in my experience, honestly, a lot of a word problem is just kind of filler information. There's really only a small amount of the word problem itself that really guides you in answering the question. So if you can just take that specific piece to help solve your problem, then that'll help out as well. So when I get to a couple of word problems a little bit later, then we're going to I'll show you what I mean and kind of break it down like that. Great question. I know word problems are a common one. All right. So with that being said, I'm going to go ahead and hop into a couple examples. Again, I'm going to focus on the four different categories. We're going to start with basic math, and then we're going to go from there. But again, if you have any specific ones, drop them in the chat, and we'll go to those. All right. So basic math. We're going to look at ordering fractions and decimals. Like I said, this is a common type of problem you may see on the non-calculator section, because obviously if you can jump these numbers into a calculator or drop them in there, it's easier for you to figure it out. So they want you to be able to do this without a calculator. And so the question asks you to order the numbers 3/8, 0.5, 1/4, and 0.9 in order from smallest to greatest. And so for me, the way I like to approach these problems, like I said, is I will turn my fractions into decimals. One, just because I don't like fractions, to be honest. And two, just because it makes it easier for me to compare the values. So earlier I said that it's really a helpful tool for you to learn the values of what I call kind of unit fractions, like 1/4. And then, 1/3, 1/5, all of those, because it helps you identify the values of other fractions. So if I look at 1/4, if I wanted to write this as a decimal, to me, when I think of a fourth, I think of a quarter. Just easier for me to say that. If I think of a quarter, I think of 25 cents, which I know is 0.25. So there it is, my decimal representation. Now, the other fraction here is 3/8. So I may not know 3/8 right away, but if I've studied and I know that 1/8 is a certain value, I can just take that and multiply it by 3, because 3/8 is just 3/8, literally. And so I know after studying for a while that 1/8 is 0.125. So 1/8 equals 0.125. So in order to divide 3/8, I just need to take this decimal and multiply it by 3. So 0.125 times 3 is 0.375. So now I have 4 different decimal values. It's easier for me to order these from least to greatest or smallest to greatest. And so let's do that. The smallest between these 4 numbers is 0.25. And really what I'm doing here is I'm looking basically at the first digit after the decimal point to start my comparison. So I have between 2, 3, 5, and 9. The smallest is that. So my smallest value is a 4th. And then after that, it actually happens to be the other fraction, 3/8, because that's 0.375. And then after that, 0.5 is the next one. I know that. And then that leaves 0.9 as the largest of those 4 numbers. So there we go. I have my values in order from smallest to greatest. And again, even though that you have transitioned your fractions into decimal values, if this was a multiple choice question, you would see all the answers written in their original form. So they'd be back into the fraction form. That's why I'm writing it like this. All right. So let's take a look at another example on basic math. All right, so we're going to look at ordinary fractions again, but they're going to look at it in a different perspective. They are asking me, between which pair of decimals listed below should the fraction 3/7 be placed here, or on a number line? Okay, so 3/7. The fractions involving sevenths are an interesting one. I actually did an entire video, or a good part of a video on the fraction 1/7, because it has a unique decimal representation. It's what's called a repeating decimal. And what I mean by that is the decimal just goes on and on and on forever. And actually the value is, when you look at it, oops, that should be 7. Let's change that. 1/7 is the decimal 0.142857 forever and ever. It's that same repeating value. And that's cool because the other nice thing about it is as you progress from 1/7 to 2/7, 3/7, 4/7, 5/7, you have this same repeating fraction, you're just starting at a different place. So what I like to do is I like to think of 1/7 is basically like 0.142. So approximately 0.142 or 0.14. Because that helps me know that, all right, if I have 2/7, I'm just kind of multiplying that by 2. If I have 3/7, I'm multiplying it by 3, and then et cetera, et cetera. So if I were to take 0.142, or let's call it like 14-ish, multiply it by 3, that gets me 42. So I know that I'm going to start now at the 42 area. My 3/7 is going to be 0.42857 ... So 0.428 is going to be between 0.4 and 0.5. And there's my answer. All right. I think I have one more set of examples on basic math, and we're going to jump to other content areas. And again, if you have any specific questions you want me to cover, drop them in the chat and I'll be sure to adjust them. Whether it's on Instagram or YouTube or Facebook, we're monitoring the chats and we'll be happy to help you out. Okay, real quick with these examples, because these are meant to be super quick problems. What really helps is if you understand the rules of exponents. And so there's 3 different types of examples here. And the rules are, if you have a number with the same base And what I mean by base is like the bigger number here, the 2, the 3, or the 2 at the bottom there. If you have a number with the same base, if they have different exponents, if you are multiplying those numbers together, all you have to do is keep the base the same and then add the exponents. So this is the same as 2 to the 9 plus 4, which is 2 to the 13th. There's your answer. You're done. Took like 10 seconds. All right. What I see people trip up the most on this is they want to multiply the 2's together, so you get like 4 to the 13th or 4 to the, some other exponent. And really, you're overthinking it. It's really as simple as keep the base the same, add the number, add the exponents if you're multiplying the values together. With division, it's the opposite. You're going to keep the value the same. You're going to keep the base number the same, in this case 3. But instead of adding the exponents, you're going to subtract the exponents. So 11 minus 7 is going to be 3 to the 4th. And there's your answer. You're done. Last one I have is if you have a base raised to a power, and then that whole quantity is raised to another power, what you're going to do is you're going to take the base, keep it the same, and instead of adding, instead of subtracting, you're going to go ahead and multiply the exponents. So 3 times 5 is just 2 to the 15th, which is a surprisingly large number if you were to actually type that in your calculator. But that's all it is. So really, that's what these problems are meant to do, is help you understand the rules, and then you could fly through them. All right? So that's some examples of some basic math problems. Let's go ahead and jump to some other types of problems you may see. I'm going to go ahead and skip over this one because I know that I have other ones that I think are a little more common. So I'm going to go ahead and go to those. And actually, what I'm going to do, to be honest, I'm going to skip around a little bit because I know there was a question about word problems, and I said I was going to address it. So I'm going to scroll through this a little bit. I'm going to find some word problems, and then I'll jump back to this category. So bear with me here. Let's see. Here we go. Whoops, one too many. Word problem, basic algebra. Solving a real word problem using equations. All right. So here's a word problem that says the teacher is handing out pencils to her 15 students. I know right away they tell me the specific number of students. That's an important fact. I'm going to circle that. She will give each student the same number of pencils and will keep 12 for herself. Again, they give me a number that's specific. I'm going to highlight that. And in case the student runs out. She has 102 pencils, all right? How many pencils will each student receive? Okay, so I need to figure out kind of what's helping here, or what's asked here. And so I have 102 pencils, and I have 15 students. I'm going to keep 12 for myself. I'm going to give the same amount to all the other ones. So let's kind of put all this together. So I have 102 total pencils. That's going to equal the 15 students. So 15 times some amount of pencils, which I'll call P, plus I'm keeping 12 for myself. So all of a sudden I have this equation that is put together using the different pieces. I need to solve for how many pencils each student is going to get. And so, the thing I said about equations is that you solve them using the opposite operation. So if I read this, my variable is P. What am I doing to my variable? I am multiplying by 15 and then adding 12. So to go in reverse, instead of adding 12, I'm going to subtract 12 from both sides. And when I do that, I get 90 over here. And then this goes away. So subtract 12, and then the opposite of multiplying by 15 is dividing by 15. 15, 15. When I do that, I get 6. If you're not sure what that is, type in your calculator, you get 6. So that means each of her 15 students are going to get 6 pencils. And there you go. Break it down step by step, highlight the important numbers, and you will get your answer. All right. So let's see. I do have another word problem. I'm going to jump to that in a little bit here. And I'll go back to these earlier ones. Whoops, sorry. This is the word problem I'm going to go through. This is a little more of an advanced word problem because it has to do with solving what's called a real-world quadratic equation. So one of the requests that I got was on quadratic equations. And so this will be kind of a mixture between those. As you may have seen, I have some other quadratic equations that I'll cover a little bit later. But this is kind of using it in a word problem. All right. This one says a ball is thrown in the air from a height of 3 meters at a velocity of 14 meters a second. The height of the ball can be calculated by the equation this, which means I'm going to use this because it's an equation they give me. So it has to be important. They tell me t is the number of seconds and h is the height. After how many seconds will the ball hit the ground? So an important piece of information about this is that we're looking for when the ball hits the ground. And when the ball hits the ground, the height of it is 0 because it's on the ground. So that is an important thing for me to look at plugging into the equation they gave me and solving. So I'm going to rewrite this equation as negative 5t squared plus 14t plus 3 equals, in this case, h, the height we're looking for is 0. And this is important because the way it's written now, what I have is a quadratic equation. And how do I solve quadratic equations? Well, I open up my formula sheet and I see that there is a quadratic formula right here. So I need to use that formula and plug in the values I need to solve. All right? So quadratic formula is x equals negative b plus or minus a bunch of stuff, all that. If you're interested, I will not be singing this. There is a song that goes to this, apparently, I've heard. I would not sing it, sorry, but if you want to look it up, go for it. I'm sure it's on YouTube somewhere. Have fun. Anyway, what you're looking at with this is plugging in the A, the B, and the C. And the way it works is your first number is A, your second number is B, your third number is C. So A, B, C. So x equals negative b, so negative 14 plus or minus square root b squared minus 4ac, so minus 4 times the first number times the third number. All of that divided by 2 times the first number, negative 5. Okay. So I know I'm going to have to get another sheet of paper on this, but that's fine. But from here, you just want to start simplifying it down as much as you can. So negative 14 plus or minus. I'm going to skip a couple steps in here, but 14 squared is 196. Actually, I'm not going to skip a couple steps. Minus all that, 4 times negative 5 times 3 is negative 60. So minus negative 60 is like plus positive 60. All over negative 10. Okay? All right. Now what I'm going to do is I'm going to simplify one step. I'm going to open up a new sheet and then go from there. So negative 14 plus or minus 196 plus 60 is 256. Type in your calculator, square root of 256 is 16. All that over negative 10. All right. So now, obviously, I'm out of room. I'm going to jump to another sheet of paper and continue the problem. So this is what I have. All right. Because there's a plus minus symbol in the middle, I have 2 separate problems. Negative 14 plus 16 over negative 10, and negative 14 minus 16 over negative 10. All right? I need to solve each of those. If I do that, negative 14 plus 16 is negative 2. Nope, it's positive 2 over negative 10, which is negative 1 fifth. And then this ends up being negative 30 over negative 10, which is positive 3. So I have two different answers. Typically, you're going to get two answers with a quadratic equation. And for instances like this, really only one of them is the right answer. And you kind of have to think about it a little bit, because remember, if you go back to the original problem, they ask you, after how many seconds will the ball hit the ground? Okay, so we're looking for time. If we look at our two answer choices, negative 1/5, positive 3, you can't have a negative amount of time. That just doesn't exist in the real world. So this cannot be the right answer. It has to be 3 seconds. So this is, again, a more advanced word problem, but I broke down the information they gave me. I took the formula, I used my formula sheet, and then I solved the quadratic equation and got my answer. So, all right. So what I'm going to do now is I'm going to go ahead and, because we had some specific requests for questions on slope, I have a few different problems on slope. I want to go ahead and address those. If you do have any comments or questions in the, for the chat, we're going to address those. And we have one we're going to take a look at right now. So, all right. A lot of practice with these type of equation word problems. Right, so typically word problems are going to ask you to solve something using an equation. So what I would recommend, definitely, I have some videos out there on word problems specifically. Definitely take a look at those. I take the word problem, I break it down step by step and show you how to kind of solve those. What I would also recommend is if you go to GED.com and look at the resource that I shared earlier, they give you some examples of word problems as well, and they can help you out with that. If there's time a little bit later in this session, I can try and pull up one or two other ones and go through those. But I would recommend starting there for sure and taking a look at that. If you have any further questions on that, reach out to me and we can put together some more videos or answer your question directly. All right. So let me go ahead and jump to slope, because slope is awesome. There's a lot of different things with slope. As you can see, there's lots of things here. So slope. One of the things you have to know about slope is there are 4 different types of slope. There is a positive slope, which is basically any line that is diagonal up to the right. Looks like that. If it goes up to the right, it's positive. There's negative, which is the opposite, goes down to the right. Any line that goes down to the right is negative. There is zero slope, which is any line that goes straight across. It's a flat line. And then we have the last one, which is undefined. I'm going to abbreviate as UND. Undefined is any straight line up and down. It's undefined. So those are your 4 different types. So if you have a line that is up to the right, it's going to have a positive value. Down to the right, it's got to be negative. Straight across, flat, it's got to be 0. And if it's up and down, straight up and down, it's got to be undefined. So with that being said, let's look at the slope of a line that passes through these 2 points, 4, 7, and 1, 5. So to find a slope, there's got to be an equation for slope. And of course there is, and of course it is on my awesome GED formula sheet right here. M equals y2 minus y1 over x2 minus x1. So I'm going to use that to figure out the slope of this. The y's and x's are just the x and y values of these points. So m equals y2 is the second y value, in this case 5, minus y1 is the first y value, and then x2 is 1 minus the first x value. Doesn't matter which one you call 0.1, 0.2, as long as you're consistent. So 5 minus 7 is negative 2. 1 minus 4 is negative 3. So the slope between these 2 points is 2/3. I changed it to a positive because any negative divided by a negative is a positive. Also, any negative times a negative is a positive. So 2/3, it's a positive slope, which means it looks something like that. If I were to graph these 2 points, I would see that. All right, building on from that, what is the equation of a line that has a slope of -7 and passes through the point 4/8? And they give you two different forms of the equation, called slope-intercept form and standard form. So this I have to do a little bit of work on. They give me a slope, they give me a point, but I have to figure out how to use that to put it into an equation. So what I'm going to do is do the first form, slope-intercept, y equals mx plus b. And why I'm choosing that is because I have a y value, it's my y and my point. I have an x value, it's the x value. I have m, because they told me the slope is -7. I just need to solve for b. All right. Whoops. All right. So let's go ahead and plug in the values we know to solve for that. So y, which is 8, equals m, which is -7, times 4 plus b. Do a little math. I get 8 equals -28 plus b, and then add 28 to get b by itself. I get 36 equals b. All right. Now I can plug that back into my form. I get y equals -7x plus 36. So there is slope-intercept form. That's the equation of a line that has a slope of -7 and passes through the point 4/8. Now the standard form, sometimes you see answers in what's called standard form, ax plus by equals c. And so what I can do is I can transition this equation, kind of manipulate it a little bit to turn it into standard form. Basically, I need to get the x value and the y value or term on one side and the c, which is usually just a number, on the other. So what I'm going to do is I'm going to take and rewrite this. And I'm going to go ahead and bring my -7x over to the other side by just adding it, because that's the opposite of -7, just +7 or +7. What that does is it gives me 7x plus y equals 36. And now it's in the same form of ax plus by equals c. So there's two different ways you may see this. All right. So it looks like we have a couple comments in the chat. I'm going to see if there's any to address right now. We're going to go and throw one up. All right. So I like the first one you did. Thanks. Good with solving equations by themselves. I have difficulty putting them together in a word problem. I just need to keep practicing the skill. Yeah, definitely. I can't encourage enough that practice definitely helps, especially with math. I know that, one of the reasons why I'm able to kind of take these and know what to do is because I've practiced and practiced over the years. I've, seen the different types of problems. So I kind of have an idea of where to start and how to put them together. So definitely practice is going to help out no matter what. But I think also what would help is, I mentioned earlier how there are specific phrases to look for, such as more than, less than, twice, 4 times a number, things like that. That'll help you put the equations and expressions together to kind of formulate them. Because it sounds like once you can formulate the equation, you're good, you know how to solve those. So I encourage you to definitely look at that, practice that, and become familiar with the different phrases that can be translated into words and numbers. Typically, whenever they give you a specific number and obviously an equation, it's going to be part of that expression or that equation to use. So keep practicing. And if you have specific ones you want me to address in a future video, let me know and I'll be sure to do that for you. All right. I'm going to go ahead and jump to another example on slope. Again, if you have comments, drop them into the comment question box and we'll be sure to address those. All right. So now we have kind of another step further with slopes. We have the same 2 points we looked at before. but they ask us what is the equation of the line that passes through those 2 points. So we figured out the slope in a previous example, which is one thing we have to definitely find. And from slope, we need to figure out the other pieces of it. So if I jump back a couple of pages, I have the slope is 2/3. All right, so I'm going to use that. So I know that m equals 2/3. I need to also figure out the y and the b. Actually, I need to figure out the b in this. So what I can do is I can take one of my points and use the x and y values along with m and plug it in to solve for b. So I'm going to use my second point just because the numbers are smaller. So y is 5 equals 2/3 times 1 plus b. All right? So now we just need to go ahead and solve this. I have 5 equals 2/3 plus b. To get b by itself, I just subtract off 2/3 from both sides. And I have then, what is this? That's going to be 4 1/3 equals b. Typically, you're going to see that as what's called an, well, what's the name of it? Oh, I can't even think of it right now. But typically, you're not going to see it as a mixed number. You're going to see it written as 13/3. Improper fraction, that's it. Yes, okay. So you're usually going to see it as an improper fraction. But anyway, so we're going to take that information, we're going to plug it in. Y equals 2/3 x plus 13/3. There's my equation. Boom, I'm done. And move on to the next problem. But again, it's kind of piecing it together. You know, first I need to find the slope. Next, I need to find, plug in one of my values using my points to solve for b. And then once I have b, put it all together. There's my answer. All right. And then I think the last one I have on slope, because I did get a specific request for looking at identifying parallel and perpendicular slopes. So I wanted to address that definitely. And so I have a question about parallel and perpendicular slopes. Again, we're using the same 2 points just to emphasize that we already know the slope. So the slope is 2/3. Okay. Now, parallel and perpendicular slopes are pretty easy, but you have to know the rule. So parallel slopes are super easy because if you have 2 lines that are parallel, they're never going to cross. And the reason is because they have the same exact slope. So a parallel slope to this is 2/3. It's the same thing. Easy enough. Now, perpendicular is interesting. There's a little trick to it. But perpendicular slopes are ones that cross at a right angle. And so they're kind of like opposites in a sense. They're called negative reciprocals of each other. And so the perpendicular slope to 2/3 or any fraction, what you do is you flip your fraction and then you change the sign. So if it's positive, you make it negative. If it's negative, you make it positive. And there it is. This is your perpendicular slope to your original one. So parallel is the same, perpendicular is negative reciprocal. And there it is. So it's a great question. I like these because they're easy to identify, but it does take practice to know the rule. So this was my quadratic. So there are other ones. I know I've skipped through some of these, so I'm going to go back a little bit to some of the other examples that I had. And again, if there are other ones that you want me to go through, I can go ahead and do that. One of the ones I want to get to is these. Because again, we've had some questions about word problems and, putting them together and, practicing and things like that. So I want to cover types of problems like that. And just as a heads up, we're going to be going live for, another 10 or so minutes. So get your comments in, get your questions in. But of course, if I don't have time to address your question, feel free to, write to us on YouTube, comment on the videos, or Facebook or Instagram, and we'll make sure to reach out to you at a later date for sure. Okay, so I had these expressions here. They basically asked me to put the words into letters and numbers. That's basically what they're asking you. So what I need to do is figure out what all this stuff means and put it into words and letters. So it says the quotient of the sum of 3 and 5 times a number and the difference of 6 less than 3 times the same number. There's a lot going on here, so let's break it down. Quotient means division. The answer to a division problem is a quotient, so I know that there's going to be a quotient, which I'm just going to represent as a fraction bar, the same idea. The sum of 3 and 5 times a number, sum is plus, 3 is easy enough, 5 times a number. So 5 times a number is like 5x, where x is the number. So there is kind of the first half of this expression. And the difference, so I know there's a subtraction problem, 6 less than 3 times the same number. So with the difference and subtraction, when you have the phrases of that, you want to kind of approach it as like the opposite. So 6 less than 3 times a number is I'm taking 3 times a number and I'm subtracting 6 from it. It's 6 less than that. And I'm using the same variable because it's the same number. So here it is. This is the expression of all those words and words and numbers there. This is the answer. So again, it's knowing what phrases to use and how to put them together. One more example of this is a similar problem, but we're looking at the product this time. So the product is any answer to a multiplication problem. And since we're looking at the product of quantities, I'm going to go ahead and write them like this, where I'm going to fill in these parentheses. So 4 more than twice a number. So I have twice a number, which is 2 times a number. 4 more is plus, and then 2 minus 7 times a number. So the difference between 2 less than 7 times a number and 2 minus is that you're minusing off the 7 times the number from the number 2. So this is the product. I put it together in letters and numbers. This is what they're looking for in their answer. All right. So there's a lot of examples here. I think I want to go through maybe 1 or 2 more, and then I want to definitely give you another resource that's available to you. And then, like I said, if you have any other questions or comments, then definitely go ahead and drop them in the chat box. But if we can't get to them, let us know. Reach out to us on YouTube, Facebook, Instagram, and we'll be sure to go from there. I actually want to go through a quadratic equation real quick. And I want to go through this because I want to show you a trick that I have used a lot when it comes to quadratic equations, especially and specifically ones where there's no leading coefficient here. It's basically just 1. Because there's like a trick that I use, honestly. And the trick is it's called factor sum method. Now, you can definitely use the quadratic equation. You can plug in your numbers. You can solve it. But I find factor sum method is a lot easier for me. The factor sum method is done by this. I know my answer is going to be broken into 2 different quantities that are going to be in expressions. I know that the first term is going to be x in both of them because the first term of my equation is x squared. So it's x times x. The factor sum method says I need to take and find 2 numbers that will multiply together to get -10, but add together to get -2. So multiply to get my last number, add to get my second number. So if I start looking at numbers that are multiplied together to get -10, well, I know that, 5 and 2 multiplies to get 10. One of them has to be negative. And actually, now that I think about this, I'm going to change that to a 3. Remix. So I'm going to change this to a 3 and write it a lot better because I know that with this method, that has to be the equation. All right, so 2 numbers that multiply to get 10, 5 and 2. One of them has to be negative, one of them has to be positive because it's negative 10. Because my middle number is negative, the negative 3, I know the bigger of these two has to be negative because negative 5 plus 2 is negative 3. All right? So now that I know my two factors, all I'm going to do is plug these numbers into my expression, negative 5 and positive 2. And now I have two simple one-step equations to solve. X minus 5 equals 0, and x plus 2 equals 0. And those are one-step equations. It's simple. You just add 5 and then subtract 2. And there's my answer. The other easy way to look at it too is once you find your two numbers you're plugging in here, the negative 5 and the positive 2, your answer is just the opposite. So because I use negative 5, my answer is positive 5. Because I use positive 2, my answer is negative 2. And those are the two values. If you use quadratic equation, you're going to get the same thing. But I really like factor sum method, especially after practicing it for a while. It's really a lot simpler. And the factor sum method works when your leading coefficient is 1, which basically means you have x squared. So if you get to that, you don't want to use quadratic formula. I encourage this method. I found it to be very useful for me. All right. So unfortunately, that's about all the time I have for this live session. Before I go, though, I do want to reference one more resource. If you're looking at taking the GED test and you're still, you would like some more information, definitely feel free to check out MathTalk on YouTube, on Facebook, on Instagram. If you're in the Palm Beach County area and you're looking at taking classes with us, I would encourage you to go to a website that is gedyes.com. It's just gedyes.com. It's our website. You can check out all the different locations that we have. Information about the GED test. You can find information about our current term, which is running right now. We're about a month in. But you can also look at the different locations that we have across Palm Beach County that offer GED classes, as well as a number to call in and reach out to them. So if you're looking at or interested in taking classes in Palm Beach County, I encourage you to go to gedyes.com, look at our locations page, find a site near you, call them up, talk to them. They're going to give you some great information about their classes as far as the time, the schedule, the expectations. We have a lot of great staff and sites that we work with. So I encourage you to check that out. But definitely check out social media. Follow me on YouTube, Facebook, and Instagram. But I appreciate all the questions and comments that have come. I hope this session has been helpful to you. And stay safe out there. And as always, thanks for watching. Have a great weekend, and we'll see you soon.